December 27, 1853, the Royal Gazette, Nova Scotia, Canada. A great discovery, weaving by electricity. The Commerce Séricole, a French commercial paper, gives an account of the remarkable invention by which it is proposed to utilize the electric current in the process of weaving. In the jacquard loom, as it is well known, the regulation of that particular order of the threads which determines the distinctive character of the fabric, and which was formerly effected by children crouched under the loom pulling cords, is at the present produced by the movement which the weaver gives himself to a treadle. The invention, however admirable, is not without difficulties and certain defects, which it would be satisfactory to overcome by still simpler means. At each passage of the shuttle there must be a piece of cardboard of a certain breadth, pierced with the holes arranged, so as to correspond with the design. And when we bear in mind that for certain designs, as many as 40,000 of these pieces of cardboard have been used, and that 1,500 are required in ordinary cases for a design of the simplest coloring, and calculate that they cost about 15 francs per hundred, it will be easily seen that these cards must be the cause of great expense as well as inconvenience. There are other objections also, of more or less importance, such as the noise which the loom makes in working, the space which it occupies, and its constant liability to derangements. All of these inconveniences are about to disappear by the introduction of electricity, the action of which is so powerful, so easy to be directed, and so prompt in its various operations. The treadle of the weaver lifts the threads and connects the extremity of each by means of copper wire with a current of electricity, either positive or negative at will, and the result is that, without any noise, some of the threads remain suspended and others descend according as the current is directed. By this means, as great a simplicity is effected in the weaving of fabrics of the most complicated nature as in that of common cloth. To direct the electricity, there is no longer need of mechanism for transferring or tracing the design. A series of points are arranged like the tooth of a comb, each point communicating with an electromagnet. The weaver will only have to pass underneath these points the design traced in varnish on a cylinder or on a metallic leaf in communication with the battery. The current will pass only where the varnish is wanting, and it will be the corresponding threads only which will remain suspended, and which by that means will reproduce the design as it came from the hands of the artist with a surprising exactitude. Instead of the expense of a design through the means of complicated cards, you have only that of the simple design and of the tending of the battery. Telegraphic experience proves how slight will be this last. There will be a saving in the most complicated designs of very nearly 3/4 of the expense, and in others certainly more than half. We shall be able, moreover, to correct and vary our designs by a few strokes of the brush, and their slight cost will permit more frequent renewal. So soon as the patents of invention, which are being applied for in every country in Europe and in America, shall be obtained, it is intended to exhibit at Turin an electric loom, worked side by side with a jacquard, producing the same fabric and the same design, the public being freely admitted. August 2nd, 1870, Boston Daily Evening Transcript, Boston, Massachusetts. Electro-Typographic Machine. A new electro-typographic machine, the invention of Monsieur Henri Fontaine, a French barrister, is now at work in one of the public offices in France. The object of this machine is to print off with economy and rapidity the quantity of short papers required in law courts, public and private offices, or commercial houses now executed by the longer and more expensive processes of printing or autography. The machine of Monsieur Fontaine, like the electric telegraph, is on the principle of substituting fixed for movable types, one type only being employed for the same letter, thus dispensing with the ponderous, bulky, movable types of the printer. Steel types, representing the different characters used in printing, capitals, small letters, italics, and etc., are arranged around two horizontal discs placed one over the other. Above these is another metallic circle, divided into notches corresponding with the type below. By a very simple machinery, as the handle or bar in the center presses against the notch representing the letter required, an electric shock lowers the type upon a sheet of paper rolled around a cylinder, prints the letter, and again returns to its place. The operation is so rapidly performed that 100 letters may be easily printed in a minute. When completed, the paper is transferred to a lithographic stone to be worked off. The great recommendation of Monsieur Fontaine's machine is its great simplicity, the ease and rapidity with which it is worked, its convenient size, about 3 feet by 2, and its moderate cost. The typography is remarkably clear and distinct from the employment of finely engraved steel types. May 28, 1909. The Ellensburg Capitol, Ellensburg, Washington. Farm and Garden. Electrifying the Soil. Interesting experiments by farmers in the north of Germany. At Hopgarten, near Berlin, Dr. Breslauer has given a practical demonstration of the fact that existing technical means admit of the crops being considerably improved at no very great cost by the application of the electric current. The experiments, which have been made for 30 years past in Sweden, England, and Germany, have led to a conclusion important for the future of agriculture. Farmers have long known that frequent thunderstorms, such as often occur in the North German lowlands during the summer months, have a very favorable influence on the growth of crops. More than 30 years ago, the Swedish professor Lemström proved that the rapid growth of plants in the polar regions was attributable to the strong electricity of the air found in those parts. Generally speaking, the first attempt to increase fertility by spanning a net charged with electricity across the fields was carried out by a Dr. Pringsheim on his property at Kristianowitz near Breslau. He succeeded in obtaining an increased production of 128% from strawberries, 120 to 140% from beetroot, and 82% in the case of beans and barley. But the necessity for always having to remove a net, which was stretched across the ground at a very low height before the usual agricultural work could be proceeded with, made the process too expensive for practical utility. The electrical engineer Neumann then tried a net with strong alternating currents, which still proved effective when erected at the height of 5 meters from the ground, in this manner no longer hindering the harvesters at their work. Experience soon showed that an equally sure result could be obtained by erecting isolated masts at intervals of 10 meters and attached to one another by thin wire. Sir Oliver Lodge was able to prove that by this system an increased production of from 30 to 40% of wheat and barley could be obtained, the proportion of glutinous flour in the grains being a higher one, so that the market price of the electrically fertilized wheat increased by 7.5%. The latest experiments, which have been carried out on a larger scale by Dr. Breslauer, were intended to convince the German farmers of the practical utility of this process.